Hello everyone, I am Nitin Ranjan from Computer Science Engineering Department. I am here to present on the topic of real-time brain tumor segmentation and classification using optimized machine learning models. First, let's see agenda. In this, I am going to explain about introduction, statement of the problem, scope of the project, methodology, how it works, output and results, test case, conclusion, future works, and difference. Introduction. Brain tumors are abnormal growth in the brain that require yearly and accurate diagnosis. MRI image is widely used, but manual interpretation is time consuming and error prone. The project used machine learning and CNN modes to automate brain tumor segmentation and classify in real time. Statement of the problem. Manual brain tumor and detection from MRI images is slow, objectives, and depends heavily on expert radiologists. Traditional image processing techniques struggle with complex tumor patterns. Scope of the project. The project focuses on developing a automated system from brain tumor segmentation and classification using MRI images. It improves accuracy, speed, and reliability of diagnosis. The system assists radiologists but does not replace professional medical judgment. And let's go for methodology. Methodology means how it works. First, collect the data, then data pre-processing, data development, then test the data, train the data. First, let's see how it's collected. Yeah. MRI brain images are collected and pre-processed using normalization and noise reduction techniques. A CNN model is trained to segment tumor regions and classify tumor types. The trained mod is then tested and deployed for real-time prediction. Let's see the architecture diagram. The system takes MRI images as input, performs pre-processing, segmentation, future extraction, and classification. CNN modes means concurrent neural network modes analyzes the image and predict tumor type. The final output displays the segment tumor regions and classify results. These are the use case diagram. The user uploads MRI images into the system. The system processes the images and perform tumor detection and classification. The results are displayed in the user analysis. Let's see the use case diagram. Class name represent all MRI brain images are represented. Attributes: image ID, image data, patient ID. Methods: uploading image, validate image. Class name: CNN model represent the CNN system and the segments of the classified tumors. Attributes: model weights, layers. Methods: train model, evaluate model, and predict tumors. The class diagram represents the components such as image input, processing module, CNN model, and output module. Each class handles specific responsibility within the system. It helps structure, design, and implementation. Let's go to the workplace workflow. Workflow. First start. User uploads an MRI brain image. Next, step two: pre-processing. Image is resized, normalized, and enhanced for quality. Segmentation. CNN model identify the isolation and tumor regions. Future extraction. We use deep futures and extract the segmentation tumor. Next, it is used for classification. Then it will display the results and end the program. These are the sequence diagram. First, an user upload an image, then it process the images, then it segments and send the results, then classify the tumor and send the results to the patient and displays the output. Algorithm used: image pre-processing improves MRI image quality through realize the normalization. CNN layers extract facial features and classify tumors. Adams optimization and category cross entropy loss are used to improve learning efficiency. Image processing, conventional neural network. These are the types we are using in a CNN: max pooling layers, dropout, batch normalization, softmax activation, data augmentation. Data augmentation is optional. Next, we going for optimizer. We are using an AdMax optimizer and learning rate. Then loss function occurs categorical cross entropy. The cross entropy used for multi-class classification problems, model evaluations, conversion matrix, and hardware and services. Hardware and software are the common processors. General processors like NVIDIA GTX, AMD Ryzen 7 9 or 5. Memory RAM 16 GB minimum, 32 GB recommended. Storage SSD with 500 GB or 1 TB. 2 this is also enough. Software programming language Python, deep learning frameworks TensorFlow. Use some libraries like TensorFlow, image processing, OpenCV for web development, Flask, HTML, CSS, Bootstrap, data handling, visualization, pandas, matplotlib. Let's go to the implementation. MRI dataset are organized into training, validation, and testing sets. The CNN model is trained and validated using these datasets. The trained model predicts tumor type for the new MRI images. First, data collection, next, pre process the data, then develop it, train and validation, then train and test the prediction. Next, here is a code segmentation part. First, train and test the data. First, CNN model architecture. First we are defining the model. For this, we are using sequential conventional network layer model. Next, compile the model. For this, we are using the optimizer, add max optimizer, then a loss function, then matrix for finding accuracy. Next, then we are training and testing the model to predict whether it is a brain tumor or not. Next, these are the outputs: training and validation. This is for training and validation loss. This for training and validation accuracy. These are the epochs. These are loss. This is accuracies. Confession matrix output. Here we go. This is the output for a classification report which we have received in our Python notebook, Google Colab. This is the output which output on web page we have run to the VS Code. The output predicted as no tumor. Let's see the test case. Different MRI images are tested to verify system functionally. Expected output are compared with the actual outputs. All test case passed successfully and confirming system reliability that you don't have brain tumor. Result. Machine learning CNN model accuracy 91%, precision 94%, recall 92%, F1 score 93, interface high accuracy in classifying brain tumor types, reliable prediction for a yearly diagnosis, assist doctor in a fast decision making. Result. No tumor 22% of 5. Okay. Conclusion. The project successfully demonstrated in a real-time brain tumor segmentation and classification system using CNN. It improves diagnosis accuracies and reduces manual effort. The system can assist doctor in faster decision making. Future work. Future enhancement include using advanced architecture like UNet and REST. Integration with the web and mobile platform is planned. I have referred to the Wikipedia for a IEEE paper book reference. Book reference KF Victor and IZ Michael. This is my GitHub link and the demo output of the project YouTube link. Thank you.